Today we're going to take a look at solving trig equations again. Before you were solving them on this interval, but now we're going to find all solutions. So we'll start with this problem, which is familiar. This was our first example in the first video. We do the same thing where we isolate the variable. So we get sine x equals 1/2. Now we know the reference angle should be pi over 6. And that sine is positive in the first and second quadrants. So in the first quadrant, our angle is pi over 6. Right, that's pi over 6 here. And in the second quadrant, we know that that should be 5 pi over 6. Now that only gives us two angles. There are actually infinitely many angles with that solution. And that is because there are infinitely many coterminal angles to these two angles here. So, if we wanted to find all of the angles coterminal with pi over 6, we would have to add or subtract multiples of 2 pi. So we write that down. We're going to add or subtract multiples of 2 pi. And then the same thing with 5 pi over 6. We're going to add or subtract multiples of 2 pi. Now we do have to state what n is, since we introduced n to the problem here. Now, in order to have multiples of 2 pi, n could be any integer, right? It could be 0 or 1 or 5 or 11 or -7. Any integer is fine. So we just note that we say n is an element of the set of integers. So make sure that you have that when you are writing infinitely many solutions. Here's another example we looked at before. We're going to combine our terms here. So we have 2 sine x. We'll subtract radical 2. And then divide by 2. Okay, now we know that the reference angle must be pi over 4. But sine is only negative in the third and fourth quadrants. So we need those reference angles. Let's see, here's pi over 4, and in here. So those two angles would be 5 pi over 4, and in the fourth quadrant, 7 pi over 4. But again, we want all the angles that are coterminal with those two angles. So we're going to add or subtract multiples of 2 pi. And once again, we make a note that n must be an integer. Now this one's going to come out a little different, because if you remember, we had solutions in all 4 quadrants. So we've got tan squared equals 1/3. So we said that tangent was plus or minus 1 over radical 3. So the reference angle is pi over 6, and that's in the first quadrant, where tangent is positive. But tangent could also be negative, right? We see with that plus or minus. So our angle could be in any one of the 4 quadrants, where this here would each measure 30 degrees. So because the angles can show up in all 4 quadrants, we can simplify the statement a little bit here. And instead of saying plus or minus 2 pi n, we can just add or subtract multiples of pi. Right? Here's our angle in the first quadrant. If we add pi, we get the angle in the third. And if we add 2 pi, we're back to where we started. 3 pi, we end up over here. So there's no need to list all 4 angles. Now we need to get the second and fourth quadrant angles. So in the second quadrant, that angle would be 5 pi over 6. And again, add or subtract multiples of pi, where n can be any integer. Okay, with this one we had to combine, or not combine, we had to bring all terms to one side, and then factor, and then we set both of our factors equal to 0. So we had cotan equals 0, or that the other factor equals 0. Now if you remember with this one, we got that cos was equal to plus or minus radical 2, which is no good because radical 2 is greater than 1. So there's no solution to this equation right here. But on the other side, we can find where cotan is equal to 0. Cotan we know is the ratio x over y, and that would be equal to 0 wherever x is 0. So last time we wrote down that our solutions were pi over 2 and 3 pi over 2. But we want all the angles that are coterminal. Bring this down here. Now x can be pi over 2, and we can say plus 2 pi n, except in this case if we add pi, we get to 3 pi over 2. If we add another pi, we're back to where we started. So we only need multiples of pi for this. And there's our solution. So here's your summary. You're going to solve the equations just as you did before when you were looking for a solution on an interval. We were just looking between 0 and 2 pi before. So everything stays the same, except that this time you've got to decide if your coterminal angles would be found by adding multiples of pi or 2 pi. And you write that down, and you remember to define n for each problem, that n is always going to be an integer.